The next topic I am going to take up is derivative as a measure of rate of change. Derivative as a measure of rate of change. Let y is equal to fx be any function. Let y change from y to y plus delta y as x changes from x to x plus delta x. This can also be written as y is equal to fx changes to y plus delta y equal to fx plus delta x. That is, as x changes from x to x plus delta x, y changes from y to y plus delta y. This can also be written as this. And therefore delta y from here is equal to fx plus delta x minus y. Delta y is equal to fx plus delta x minus y. But y from here is equal to fx. So we can write fx plus delta x minus fx. Delta y is equal to fx plus delta x minus fx. This delta y is change in y corresponding to a change delta x in x. This delta y is change in y corresponding to a change delta x in x. And therefore, average rate of change of y with respect to x is delta y by delta x. Because delta y is change in y corresponding to a change delta x in x, therefore average rate of change of y with respect to x is delta y by delta x. And instantaneous rate of change of y with respect to x is equal to limit delta x approaches 0, delta y by delta x. Instantaneous rate of change will be let delta x approach 0, delta y by delta x. But delta y from here is fx plus delta x minus fx. So substitute here, we get limit delta x approaches 0, delta y is fx plus delta x minus fx from 1 over delta x. Now this is nothing but a definition of the derivative. This is nothing but a definition of derivative. That is dy by dx. This is equal to dy by dx. Therefore, derivative can be interpreted as instantaneous rate of change of y with respect to x. Therefore, we can write instantaneous rate of change of y with respect to x is dy by dx. This word instantaneous is sometimes dropped, and we simply write rate of change of y with respect to x is dy by dx. We leave the word instantaneous and write rate of change of y with respect to x is dy by dx. And rate of change of y with respect to x at a particular point x equal to a is dy by dx at that particular point. Rate of change of y with respect to x at x equal to a is dy by dx at x equal to a. Further, if dy by dx is positive, this derivative is positive, then y increases with respect to x. Y increases with respect to x. And if dy by dx is negative, then y decreases with respect to x. If derivative is negative, then y decreases with respect to x. And if derivative is positive, y increases with respect to x. These things we will be using while solving the problems. Now we move on to the problems. First is find the rate of change of the volume of a ball with respect to its radius. How fast is the volume changing with respect to the radius when the radius is 2 centimeters. So we have to find the rate of change of volume of a ball with respect to its radius. So we must first write a relation between volume and radius. So volume is 4 by 3 pi r cube. Find the rate of change of volume of a ball with respect to its radius. How fast is the volume changing with respect to the radius? So we have to find the rate of change of volume with respect to the radius. This is to be found when the radius is 2 centimeter, when r is equal to 2 centimeters. Now differentiating this with respect to r, differentiating 1 with respect to r, what we get is dv by dr is equal to 4 by 3 pi into differentiation of r cube is 3r square. This 3 cancels with this and we get 4 pi r square. Therefore dv by dr at r is equal to 2 centimeters is equal to 4 pi into 2 square. That is 2 2s are 4, 4 4s are 16 pi. 16 pi. So rate of change of volume with respect to the radius at r is equal to 2 is 16 pi centimeter square. Next is find the rate of change of volume of a sphere with respect to its surface area when the radius is 2 centimeters. When the radius is 2 centimeters. Find the rate of change of volume of a sphere. Now volume of sphere is 4 by 3 pi r cube and surface area is 4 pi r square. We have to find the rate of change of volume of a sphere with respect to its surface area when the radius is 2 centimeters. We have to find dv by dA is equal to question mark when r is equal to 2 centimeters. Now v is a function of r and a is also a function of r. So we will use parametric differentiation. We can write dv by dA is equal to dv by dr over dA by dr and dv by dr, differentiate this with respect to r, 4 by 3 pi into differentiation of r cube is 3r square and dA by dr is 4 pi into differentiation of r square with respect to r is 2r. Now this 3 cancels with this and r cancels with this. 4 cancels with 4, pi cancels with pi and we are left with r by 2. All other terms have cancelled. So this is r by 2. So dv by dA at r is equal to 2 is 2 by 2, that is 1 centimeter. So rate of change of volume with respect to surface area is 1 centimeter. A stone is dropped into a quiet lake and waves move in a circle at a speed of 4 centimeter per second. At the instant when the radius of the circular wave is 10 centimeter, how fast is the enclosed area increasing? A stone is dropped into a quiet lake and waves move in a circle at a speed of 4 centimeter per second. Now let the stone be dropped into the lake and these be the circles that are formed. Let r be the radius of this circle at any time t. Let r be the radius of the circle at any time t. A stone is dropped into a quiet lake and waves move in a circle at a speed of 4 centimeter per second. So we are given dr by dt. dr by dt is 4 centimeter per second. These circles move at a rate of this, that is their radius is increasing at the rate of 4 centimeter per second at the instant when the radius of the circular wave is 10 centimeter. So what he says, when r is 10 centimeter, how fast is the enclosed area increasing? So we have to find dA by dt. How fast is the enclosed area increasing when r is equal to 10 centimeters? Now A is equal to pi r square. Now we have to find dA by dt. So differentiate it with respect to time t. dA by dt is equal to pi into 2r into differential of inner function with respect to t. Differential of r with respect to t. dr by dt. Now this is equal to 2 pi r into dr by dt is 4. So this is equal to 8 pi r. So dA by dt at r is equal to 10 centimeters is 8 pi into 10. That is 80 pi. So this is the rate of increase of the area enclosed when r is 10 centimeters. This is the rate of increase of the area, 80 pi centimeters square per second. Next is the volume of a cube is increasing at the rate of 7 centimeters cube per second. We are given the volume of a cube is increasing. The volume of the cube is increasing at the rate of 7 centimeter cube per second. Volume of cube is increasing at the rate of 7 centimeter cube per second. How fast is the surface area increasing? So dA by dt is equal to question mark when the length of an edge is 12 centimeter. When L is equal to 12 centimeter. L is length of an edge. Now volume V of a cube is equal to L cube. And A, the surface area of the cube is 6L square. Surface area of a face of a cube is L square. And since it has 6 faces, therefore surface area is 6L square. Now we are given dV by dt is 7 centimeter cube per second. So we find dV by dt. dV by dt is 3L square and differentiation of L with respect to t is dL by dt. Since we are differentiating with respect to t, therefore we must take the differentiation of the inner function. And therefore this is equal to 7 into 3L square dL by dt, or dL by dt is equal to 7 upon 3L square. And we have to find dA by dt. And therefore dA by dt is equal to 6 into 2L dL by dt. That is 12L dL by dt. And this is equal to dL by dt is 7 by 3L square. So this is equal to 12L into 7 by 3L square. So this is equal to L cancels, this 3 cancels with this, and we get 28 by L. 28 by L. 28 by L. And therefore dA by dt at L is equal to 12 centimeters is 28 by 12. and this is equal to 4 cancels, we get 7 by 3. 7 by 3 centimeter square per second. 7 by 3 centimeter square per second. Now next question is, an Air Force plane is ascending vertically at the rate of 100 kilometers per hour. So we are given dh by dt is equal to 100 kilometers per hour. If the radius of the earth is r, how fast is the area of the earth visible from the plane increasing at? How fast is the area of earth visible from the plane increasing at 3 minutes after it started ascending? So dA by dt is equal to question mark when t is equal to 3 minutes. Given that the visible area A at height h is given by 2 pi r square into h over r plus h. Now we are given A is this and dh by dt is this. We have to find dA by dt. So what we do is, from this equation dA by dt is equal to 2 pi r square into, here we will use quotient rule. So this will be r plus h whole square, r plus h into dh by dt minus h into d by dt of r plus h. Gx whole square, gx into differentiation of fx minus fx into differentiation of gx. So this is equal to 2 pi r square into r plus h into dh by dt. dh by dt is given to be 100 kilometers per hour minus h into dr by dt. Radius of earth is constant. So this will be 0 and we will get dh by dt. So dh by dt is again 100 kilometers per hour. This divided by r plus h whole square. So this is equal to 2 pi r square into 100 r plus 100 h minus 100 h whole divided by r plus h whole square. So this is equal to 2 pi r square into, these two cancel out and we are left with the 100 r over r plus h whole square. This is equal to 200 pi r cube divided by r plus h whole square. Now we know S is equal to u t. Therefore h is equal to u t. Now u is equal to dh by dt. This is equal to 100 kilometers per hour. So this is equal to 100 t. Now we have to find dA by dt when t is 3 minutes. At t is equal to 3 minutes, that is 3 by 60 hours. That is 1 by 20 hours. H is equal to 100 into 1 by 20. This is equal to 5 kilometers. So substituting this in 1 implies dA by dt is equal to 200 pi r cube divided by r plus 5 whole square. This kilometers per hour. This is the rate of increase of the area visible at t equal to 3 minutes. I will quickly explain you once again this question. An Air Force plane is ascending vertically at the rate of 100 kilometers per hour. Therefore, dh by dt is given to be 100 kilometers per hour. If the radius of the earth is r kilometers, how fast is the area of the earth visible from the plane increasing at 3 minutes after it starts ascending? Now we have to find dA by dt. How fast is the area of the earth visible from the plane increasing at t equal to 3 minutes? And we are given A is 2 pi r square h by r plus h. Now we find dA by dt. So dA by dt is this much. Differentiated, we arrive at this. But here we have to find dA by dt at t equal to 3 minutes. But t is not involved in this question. It is indirectly involved in terms of h. So we use s is equal to ut. And therefore h is ut. And u is dh by dt. Rate of change of h with respect to time. This is 100 t. Now when t is equal to 3 minutes, that is 3 by 60 hours, this will be 1 by 20 hours, because we are using the units kilometers and hours. So we must convert this into hours. So h will be equal to 100 by 20. 100 by 20, that is 5 kilometers. And substitute h here, we arrive at the answer. Now next is a man 2 meters high walks at a uniform speed of 5 kilometers per hour. A man 2 meters high walks at a speed of 5 kilometers per hour away from the lamp post 6 meters high. Find the rate at which the length of his shadow is increasing. We have to find the rate at which the length of his shadow is increasing. Now let this be the lamp post, and this be the surface on which the man is walking. Let this be the man, and therefore this is the shadow. This is the shadow of the man falling on the ground. A man 2 meters high. This man is 2 meters high. Walks at a uniform speed of 5 kilometers per hour. Let this be x and length of his shadow be L. Away from a lamp post 6 meters high. This lamp post is 6 meters high. Now we have to find the rate at which the length of his shadow is increasing. We have to find dl by dt. A man 2 meters high walks at a speed of 5 kilometers per hour. So dx by dt is 5 kilometers per hour. Dx by dt is 5 kilometers per hour from a lamp post 6 meters high. Find the rate at which the length of his. We have to find dl by dt is equal to question mark. Rate at which the length of his shadow is increasing. Let this be A, B, C, D and E. Now in this triangle, if this angle is say theta, then what we have is tangent of theta is equal to 2 by L. 2 by L. And this is equal to, from this triangle, tangent of theta is 6 upon x plus L. You can also use similarity of triangles. This is equal to 6 over x plus L. So we can simplify this. This implies 2x plus 2L is equal to 6L. And this implies 2x is equal to 4L. And this implies x is equal to 2L. So x is 2L. And therefore dx by dt must be equal to 2TL by dt. Now dx by dt is 5. So 5 is equal to 2 into dl by dt. And therefore dl by dt is equal to 5 by 2. That is 2.5 kilometers per hour. Length of his shadow is increasing at the rate of 2.5 kilometers per hour. The next problem I am going to take up is water is running into a conical vessel 15 centimeters deep and 5 centimeter in radius. Water is running into a conical vessel. So let this be the conical vessel. Water is running into a conical vessel 15 centimeters deep. Height of this conical vessel is 15 centimeters and 5 centimeter in radius. So radius of this conical vessel is 5 centimeters. Water is running into a conical vessel 15 centimeters deep and 5 centimeter in radius at the rate of 0.1 centimeter cube per second. So we are given dV by dt is equal to 0.1 centimeter cube per second. Centimeter cube is unit of volume. Centimeter square is area and centimeter is length. So this is units of volume. If you have any confusion, you can determine it from here what is given. Water is running into a conical vessel 15 centimeters deep and 5 centimeters in radius at the rate of 0.1 centimeter cube per second. So we are given dV by dt is 0.1 centimeter cube per second. When the water is 6 centimeter deep, find the rate at which water level is rising. First we have to find the rate at which water level is increasing. Let at any time t this be the water level. Let this be h and let the radius be r. Let the radius be r. At any time t, let h be the height of the cone and r be its radius. So what we have to find is find the rate at which the level of water is rising. Water level is rising. So we have to find dH by dt. dH by dt is equal to question mark when h is equal to 6 centimeters. Find the rate at which the water level is rising, and in second part we have to find the water surface area is increasing. This water surface area is increasing. So we have to find dA by dt is equal to question mark when h is equal to 6 centimeter. And in third part we have to find the wetted surface area of the vessel increasing. Wetted surface area. Wetted surface area is this. This is the wetted surface area. Let this be called A dash. dA dash by dt is equal to question mark when h is equal to 6 centimeter. Now I start with the first part. Now we are given dV by dt is equal to 0.1 centimeter. Now volume of a cone is 1 by 3 pi r square h. This is the volume of the cone. Volume of cone is 1 by 3 pi r square h. Now we express this in terms of a single variable, that is h. What we do is, from here let this angle be alpha. Then what we do is, tangent of alpha is equal to, how much is tangent alpha? Tangent of alpha is r by h. This is r by h, and this is equal to, from this triangle, this is equal to 5 by 15. This is equal to 5 by 15. So we have, this is 1 by 3. So we have h is equal to 3 r. We get the relation h is equal to 3 r. Therefore, we can write v is equal to 1 by 3 pi r square h is equal to, and this implies r is equal to h by 3. So this is equal to, now we express it in terms of h. This is 1 by 3 pi h square by 9 into h. That is equal to pi by 27 h cube. Now we are given dV by dt is this much. Differentiate this with respect to t. dV by dt is equal to pi by 27 into 3h square into dh by dt. And this implies dV by dt. dV by dt is 0.1. This is 1 by 10. 0.1 is 1 by 10. So 1 by 10 is equal to pi by 27 into 3h square into dh by dt. This 3 cancels with the, and we get dh by dt is equal to, this is 9 by 10 pi, 9 by 10 pi into 1 by h square, and this implies dh by dt. We have to find dh by dt at h is equal to 6 centimeters. So at h is equal to 6, we have 9 over 10 pi into 1 by 36. 9 fours are 36. So we have 1 by 40 pi. 1 by 40 pi centimeter per second. So dh by dt is 1 by 40 pi centimeter per second. So first part is solved. Now we find the second part. The water surface area is increasing. At what rate the water surface area is increasing? Water surface area is this. That is A is equal to pi r square. And we have to find dA by dt at h is equal to 6 centimeter. And we have this relation with us. The water surface area is A is equal to pi r square. And this is equal to pi into r square. R is h by 3. So this will be h square by 9. And we have to find dA by dt. So dA by dt is equal to pi by 9 into 2h into dh by dt. This is equal to 2 pi by 9 h into dh by dt. Now dA by dt at h is equal to 6 centimeters is 2 pi by 9 into 6 into dh by dt at h is equal to 6 is, we have solved this in the first part, this will be equal to 1 by 40 pi centimeters per second. You can see the second equation. This cancels with this. 3 2s are 6, 3 3s are 9, 2 2s are 4, this and this cancel with this. Pi cancels with pi. And this is equal to 1 by 30 centimeters square per second. Area is in centimeter square per second. And third part is the wetted surface area of the vessel increasing. The wetted surface area A dash is equal to pi r L. Pi r L. L has been marked in red color in this figure. From triangle OAB, what we have is L square, hypotenuse square is equal to R square plus H square, base square plus height square. This OAB is a right angle triangle. So we have this. Now we have to express this in terms of H. Let this be 3. So what we get is L square is equal to R. R is H by 3. R is H by 3 whole square plus H square, and this is equal to H square by 9 plus H square. This is 10 H square by 9. Therefore L is equal to root 10 H by 3. Root 10 H by 3. Substituting in 3, we have A dash is equal to pi into R. R is H by 3 from equation 1 into L is under root 10 by 3 H, and this simplifies into under root 10 pi by 9 under root 10 pi by 9 H square, and we have to find dA dash by dt. So this is equal to under root 10 pi by 9 into 2h dH by dt, and therefore dA dash by dt at h is equal to 6 is under root 10 pi by 9 into 2 into h is 6. So 6 into dH by dt is 1 by 40 pi. 1 by 40 pi. So this is equal to, now this pi cancels with this. 3 2s are 6, 3 3s are 9. So what we get is 4 root 10 over 3 into 40, and now this cancels with this, and therefore the answer is root 10 by 30 centimeter square per second. Now next question is, sand is pouring from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. Height is always 1/6 of the radius of the base. How fast is the height of the sand cone increasing? So what we do is, sand is pouring from a pipe at a rate of 12 centimeter cube per second. So we are given dV by dt is equal to 12 centimeter cube per second. The falling sand forms a cone. Now this sand forms a cone. the falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6. So this is, say, H, and this is the radius R. Now it is given that the falling sand forms a cone on the ground in such a way that the height of the cone, that is H, is always 1/6 of the radius. This is always R by 6. How fast is the height of the sand cone? dH by dt is equal to question mark. How fast is the height of the sand cone increasing when H is 4 centimeter? Now we have converted this whole question into a mathematical statement. Now we solve this. Let this be O, this be A, and this be B. Now we are given dV by dt is this much. Now volume of the cone is 1 by 3 pi r square H. And this is, now H is given to be 4 centimeters, so we shall convert this in terms of H. So this implies R is equal to 6H. So what we do is we write this is 6H whole square into H. So this is 1 by 3 pi into 36H cube. This 3 cancels with this, and we get 12 pi H cube. Now dV by dt will be 12 pi into 3H square into dH by dt. That is 12, dV by dt is 12. 12 is equal to 12 pi into 3H square dH by dt. This 12 cancels with this, and we get 1 by 3 pi H square is dH by dt. We have to find dH by dt at H is equal to 4 centimeters. So dH by dt at H is equal to 4 centimeters is 1 by 3 pi into 4 whole square. This is 1 by 48 pi. 1 by 48 pi. This is simple. You can try it. First thing is read out the statement and convert it into a mathematical statement. Then you will not have to read the statement again and again. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. Write dV by dt is 12 centimeter cube per. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius. Height is always 1/6 of the radius. This statement has been converted into a mathematical form. How fast is the height of the sand cone increasing? How fast is the height of the dH by dt is to be found when H is 4 centimeters. Now this is the whole statement. Now you can easily solve it. Now we take up the next question. As I have illustrated you in the previous questions, questions of this type involve the following process. First is read out the question and understand the statement. Second is read out the question again, convert it into a mathematical statement and draw the figure. And third is then solve the question. First read out the question and understand the statement. Second is read out it again and draw the figure and convert the question into a mathematical statement. And third is then you solve the question. So first I will read out the statement. Water is dripping out from a conical funnel at a uniform rate of 4 centimeter cube per second. So dV by dt is 4 centimeter cube per second, through a tiny hole at the vertex in the bottom. When the slant height of the water is 3 centimeter, find the rate of decrease of the slant height of a water cone. Given that the vertical angle of the funnel is 120 degrees. Now water is dripping out from the conical funnel, that is dV by dt is 4 centimeter cube per second. Now let this be the conical funnel. And let this be the water dripping out from the conical funnel. Therefore, as the water drips out, the volume of water in the cone will decrease. Therefore, we must take a negative sign here. Water is dripping out from a conical funnel at a uniform rate of 4 centimeter cube per second. The volume of the water is decreasing at the rate of minus 4 centimeter cube per second. Let at any time t this be the level of water in the conical funnel. Let this be L, that is the slant height be L, and let radius of the water surface be R. This be the radius of the water surface. Let us say this as O, A, B, C, D, E. Now this angle is given to be 120 degrees. Given that the vertical angle of the funnel is 120 degrees. This angle is 120 degrees. So this angle is 60 degrees and this angle is also 60 degrees. When the slant height of water is 3 centimeters, that is when L is equal to 3 centimeters, find the rate of decrease of the slant height. We have to find dl by dt is equal to question mark when L is 3 centimeter. Find the rate of decrease of the slant height of water given that the vertical angle is this angle is 120 degrees. So this is 60 degrees and this is 60 degrees. Now we solve the problem. Now V is equal to 1 by 3 pi r square h. But we have to find dl by dt. So what we do is we express this in terms of L. Now in triangle AEC, cos of 60 degrees is equal to cos of 60 degrees is this, say this height is h is equal to h by L, and sine of 60 degrees is r by L, and cos of 60 degrees is half, so half is equal to h by L, and sine of 60 degrees, so sine of 60 degrees is root 3 by 2. This is equal to r by L, and therefore h is equal to L by 2 and r is equal to root 3 by 2 L. Substituting in 1, what we get is V is equal to 1 by 3 pi r square. R is this much, root 3 by 2 L whole square, and H is L by 2. So this is L by 2. This is equal to pi by 3 into 3 by 4 L square into L by 2. This 3 cancels with this, and we have pi L cube by 8. This is equal to pi L cube by 8, and therefore dV by dt is equal to pi by 8 is constant, and differential of L cube will be 3L square dl by dt, and dV by dt is minus 4 centimeter cube per second. this is equal to minus 4, and this is 3 pi by 8 L square dl by dt, and therefore dl by dt is equal to minus 32 over 3 pi into 1 by L square, and therefore dl by dt at L is equal to 3 centimeter. L is equal to 3 is minus 32 by 3 pi into 1 by 3 square. 3 square is 9. This is equal to minus 32 by 27 pi minus 32 by 27 pi. This centimeters per second, and therefore the slant height of water in the cone is decreasing at the rate of 32 by 27 pi. Minus sign indicates that this quantity is decreasing, that is the slant height is decreasing, and this is the rate at which it is decreasing. If it is positive, then it would have increased, then it would have increased. Minus sign indicates that the slant height is decreasing. So this is the answer.